Hi everyone, I'm Bipin. I lead the API management team at Autodesk, and my talk is on managing tens of thousands in transactions per second in a cross-cloud architecture with high availability. Um, Before we go into the topic, quick intro about Autodesk. When we ask about Autodesk to the audience, the typical answer comes is that they are aware of it. And then when I follow up with a question on which products of Autodesk are you familiar with, the typical answer is AutoCAD. Uh, I myself joined Autodesk a year back, and turns out it has hundreds of um, almost 100 different products in multiple industries. This is just one snapshot, a small bit of those products that are out there built by Autodesk. Uh, this is Avatar you are all familiar with. Did you know that multiple Autodesk products were used in the 3D animation, modeling, rendering, and different parts of the production process? Similarly, this is the Shanghai Tower. Again, several Autodesk products were built, right, were used in designing, construction, and the entire management of the supply chain inventory around the construction of this particular architecture marvel. In summary, a lot of products that we see and use in our day-to-day lives have gone through some kind of design or make process that involved one or more Autodesk solutions. That brings me to our mission, which is we believe a better world can be designed and made for all. And with that, I'm going to talk about Autodesk's design and make platform. So the platform offers 3 industry clouds to help you manage your assets and workflows. Fusion is the industry cloud for manufacturing, connecting everyone throughout the product lifecycle. Forma is the industry cloud for architecture, engineering, construction, and operation, uniting teams from design to build to operate. Flow is the industry cloud for media and entertainment, bringing together the entire production lifecycle. But today's focus is going to be on Autodesk Platform Services. Autodesk Platform Services provides a cross-industry set of API shared capabilities and services that connects workflows across our industry clouds, products, and other solutions. With APS, you can personalize your technology system to create custom end-to-end workflows. Quick look at the agenda. We'll cover a refresher on API Gateway because that's the platform that we are going to talk about in this session. We'll share the story that we went through as part of one of the transformations we did, potential issues we ran, how did we solve it, and what alternative options did we also explore. With that, let's move to the API Gateway refresher. API Gateway serves as a reverse proxy between clients and backend services. After receiving incoming client requests, API Gateway manages a number of responsibilities, including rate limitation, routing, authentication, protocol translation, monitoring, so on and so forth, before or after it sends the request to the backend services for processing. In addition, I want to call out about the terminologies north, south, and east, west. North, south is typically referred to the traffic that is coming from outside your company's networks. That's typically coming from the client, request coming inside, or your responses going outside. Similarly, east west is the traffic that is between the services that the company owns. So these are traffics within the network of the company. So with this refresher, let's move to the API Gateway story. Once upon a time, not too long ago, Autodesk was in this sort of a setup. As I said, we have a lot of products, so they have their own business services, which are backed by a lot of foundational services. These could be your identity service, this could be your data management or notification service, billing, order, and so on and so forth, right? All these are within Autodesk services. So they constitute the east-west traffic. And so we used to support it through an east-west gateway. Our customers connect to us via the developer portal. They create an account in developer portal. They then create apps, generate tokens, and once that's done, they can call our APIs. And this API request is handled by our north-south gateway, which is on Apigee. And we used to manage tens of thousands in transactions per second in this particular setup. So everything was going fine. And on one fine day, all this was on AWS. But then on one fine day, Google comes into the picture. Google acquired Apigee. And of course, the first thing is rebranding. For some period, the setup for us did not change. We continued to have two service providers. One is AWS for all the infrastructure, and then Google for Apigee. So at this point in time, while we were paying Google for the Apigee services, Google had to pay AWS for the infrastructure that Apigee was using. So after some time, Google came up with the newer version of Apigee called Apigee X, which is on GCP. So we were given three options. One is, or rather, we had three options, right? We could move to Apigee X, but that's on GCP, or we could switch to, we could continue to be on AWS, but then it's called the hybrid setup, wherein Google will only own the runtime, the logic, the deliverables, but the infrastructure would have to be maintained by Autodesk. If we chose the option to go to GCP, both the infrastructure and the runtime would be owned and maintained by Google. We also had a third option, which is to switch to another gateway. And we did our own research of the use cases that we have, and we compared. We did an industry comparison of all the market players, and we decided. And this particular slide from Gartner, the Magic Quadrant, also emphasizes that our provider was a industry leader, and so we decided to continue with Apigee. So the options that we had to choose was, do we move to GCP or do we stick with AWS? AWS, Apigee, where we had to maintain the infra. Given all the pros and cons, we did a cost-benefit analysis, and we decided to move to Apigee. We did POCs, and they were promising, and that led to taking of that decision. So, and then this happened. We had to come to this setup now. Apigee is moving out of AWS into GCP. So all our traffic from our customers, before they reach our backend services, first go to Apigee in Google, and then they hit the backend services in AWS. So an additional network hop was happening for every transaction. We explored a few options, and one of the setups or recipes that we tried on was this. Basically, it's a multi-region active-active setup for the Apigee gateway. As close as possible mirror our region availability for the backend services as well, and a global load balancer in the front that redirects traffic based on location affinity of the clients. And some things to note here are the traffic between Google and AWS is going through the public internet. And we also had some systems where the backends, I'm calling them here as API targets. They were calling each other not through the API gateway, but sometimes through APG because of the feature sets that APG provide. As a platform, we gave our customers, the internal customers, the flexibility to choose either of the gateways. So we had to support even this use case where a call from the users coming all the way to the backend might again come back into the public internet to Apache, right? So there could be calls multiple calls coming into Apache for the single user call sometimes. We migrated to this setup, and since then our traffic has also significantly increased, but it has helped us to sustain the traffic. We did face some issues, and we learned and we improved on it, and I'm going to now talk about those issues. When I asked in the audience, they were uh, they rightly guessed the issues, which was latency and availability. Because there's an additional network hop involved and sometimes multiple network hops between the two cloud service providers, latency was a probable issue that one might encounter. But luckily for us, that didn't happen. When we moved from the set, when we made the switch, we took a comparison a week before and after, and we noticed the overall latency had in fact gone down. This was attributed not definitely not for the additional network hop, but rather for the fact that we were also moving from an older version of the gateway to a newer version. So the newer version did have performance improvements that helped us reduce the overall latency even after the switch. One more point to note is we did this comparison just 1 week before and 1 week after the switch. The reason being, as a gateway, when we are looking at the average total response time, this involves not just the time taken by the gateway to process a request, but it includes also the latencies of every backend service that was called from the gateway as part of the request. So after the switch, if there were changes in the backend services that brought in additional latency inherently, that would also reflect in the gateway metrics. So it wasn't helpful to continue track the before and after metrics for a prolonged time. Um, After the first week, we did continuously monitor the latency from a trend perspective, and except for a few cases where a particular endpoint or particular backend noticed latency, which was specifically because of either the configuration that they were in or the content that was being processed or sent through the networks. We did not encounter any latency issues across the board. The next issue that we noticed was around availability. That definitely did not have a single root cause, it had multiple. One primary one was NAT port exhaustion issues during peak traffic periods. If I move back to this particular image, if you notice, for every region now, because there is a traffic that is going out of the network, we have to enable cloud NATs for every region. And when there's a NAT, there is an IP and a port. So there's a limited amount of ports attached to every IP that's possible. And if we have not provisioned enough, for during the peak traffic, we might face port exhaustion, in which case, beyond certain threshold, the subsequent request will get failed. So we noticed this as part of our production monitoring, and the way to mitigate this was to provision additional NAT IPs. Sometimes this looks simpler, but sometimes there could be a scenario where your backend might have IP whitelisting. So each time before you add a new IP, they might have to why this IP might need to be whitelisted in the backends as well. So depending on the setup in a company, this particular issue might be a easy or slightly time consuming to implement. Second issue was around hardware upgrades in the data center, in the routers, in the network components. Um, there is no easy or common fix here other than going deep diving in every instance, working with our um, uh, cloud providers and identifying the fixes and ensuring that gets implemented. The reason we called this out was before we went into a cross cloud setup, this was limited to the hardware, the infra of one provider, whereas in a cross cloud setup, that this particular issue is amplified because we have multiple clouds, multiple providers, and so on. The third issue, which was sort of something that we didn't have control over, was the internet network packet loss. So what used to happen was whenever a request goes from, let's say, our north-south gateway into our backend, because it's going to the public internet, sometimes the network, the requests are lost and they don't reach the backend ALBs. Or when the backend is trying to send the traffic through the public internet back to the north-south gateway, it might get lost. So we noticed this. There is no easy solution for this because um, if something is lost in the public internet, we don't have control since it's not a dedicated network. But there are solutions there are other architectural setups that can be considered. We did evaluate a few of them, so let me go over those now. The first is the default setup, the one that we just discussed, having um, the north-south gateway in one cloud. Here I'm taking the example of GCP, the backend being here the example is AWS. Um, it's active on both sides, and in between them is just public internet. We discussed the issues that we noticed as part of the setup. The alternative setup that is possible is cross-cloud interconnect, wherein this is a product that helps you establish high bandwidth dedicated connectivity between any two cloud service providers. So there is no internet involved, no public internet involved, and the risk of packet loss is greatly reduced. Third option for an alternative is partner cross cloud interconnect. Here, there is a third party other than the two cloud service providers who help with the dedicated networks between the two cloud service providers. And this particular setup is also a recommended setup when on one end is a cloud and network, and on the other end you have a um, on-prem network. So partner cross cloud interconnect can serve both purposes. One where two clouds are getting connected, and you want to avoid and you want a dedicated network connectivity. Um, as well as when you're connecting a cloud with the on-prem network. We did evaluate three options, and in summary, of course, the default option is the easiest to implement. Is the doesn't require any additional private connectivity, and again, it's the most common one you would find out there. With respect to connectivity, the cross cloud and the partner cross cloud both give private network connectivity and thus reducing packet loss as compared to default. Latency wise, cross cloud interconnect is the lowest because there's no third network involved there, whereas the default is has a potential latency, but again, it's variable. It's not something that's deterministic. Um, Performance wise, cross cloud interconnect is probably the fastest because it guarantees the fastest speeds. Uh, Cost wise, of course, the default is um, the lowest cost because there's no additional infra required. But do note that it, because there is additional egress traffic going out from a cloud provider, we need to provision the NAT IPs, and that is usually charged by the providers. So there's some extra fees, and so it's not totally zero. In our case, we evaluated the pros and cons. Default isn't bad. Default might work 90% of the time. Depending on the enterprise you're looking at, the scenarios, you might also want to consider the other two options and choose whichever is the best for your use case. And that's my talk. Thank you.